So the first thing is z is cosine theta plus I sine theta. So same thing. What is mod z? Mod z is equals to 1. Right? Because z is equals to r cosine theta plus I sine theta. Or equals to re theta. So if this is just this one, so it means the r is 1. The modulus of r is 1. That is the first thing. The modulus of z is 1. This complex number here. Prove that cosine cot theta over 2. So it's very similar to this theta over 2 here. So like I say, go to the question bank. Search for the concept which is manipulating theta over 2. Okay, so that's the first one. In the mini revision set, we have also done quite a significant of it already lah. So just take note. So from left hand side, 1 plus z over 1 minus z. What's the easiest way to do? Don't use trigo ratio to solve it. You will take a long while. So you know that if z is equals to cosine theta plus I sine theta, this is just a Euler's identity. So it's ei theta. Okay, so that's the first thing. So manipulate it using exponential form. Okay, that is the exponential form. Manipulating it should be quite okay. Now there are a few ways. Some students like to multiply. Okay, I'll just show the 2 ways lah. So whichever method you prefer, you just stick to it. Some students like to what I like to multiply lah. Okay, so I like to multiply top with e minus theta over 2. My whole goal here is so that the power becomes half. So this is method 1. You understand why method 1? Method 2 is that you just change it, factorize it out. So one is 0, so it's e0i, right? Okay, e to the power 0 ma. So this one here you can change it to e theta over 2 minus theta over 2 because it's 0. So ei theta over 2 plus theta over 2. Actually, they are the same thing lah. So ei same thing, huh? Yeah. So method 2 is you factorize. Method 1 is multiply. I tend to use the method 1 more because it's easier. You can see why it's easier. One is just let this be 0 because this is e0, 1 here. Okay, so you just do whatever you think you prefer. So I prefer the first one. So this is e minus I theta over 2. E okay, like that. Method 2 will then be factorize it out. Go. This part here. If you can skip step by all means, for method 2, you can actually skip step also. Going factorizing. So both will give you the same thing. Cancel this out. You still get the same expression there. So you both arrive at the same thing. So cosine So many things to write. Then then I can just cancel this one. Then I could also cancel the bottom one. What is left is 2 cosine theta over 2. Multiply bottom with I, multiply top with I. You get is it? Okay, so manipulating theta over 2, very common. Now, so you have got 0, z, 1, z, and 1 plus z, 1 minus z respectively. Okay, then you're told to indicate O, A, Z, P plus Q on the Argand diagram. So try and draw to scale. Make it this page first. First of all, we already established, right? So this is what's going on. We have O, which is here. Okay, then 1 unit now. 1 unit. 1. So O done. 1 will be here. This is A, right? So this is 1. 1 A. Then after which you have a Z. Okay, Z is remember modular of Z is what? 1. Now this is important. If at the start of a question, right, you didn't identify that mod Z is 1, messed up. You're gonna pay big time for this part here. So just make sure you understand that this mod Z is 1. So what does it mean? It means that if you were to draw a circle, let me just explain. You don't really need to draw a circle, but if you draw a circle, okay, can you see? Can see, right? So you draw a circle like that. Say this is a circle, okay? Here. This is not exactly a circle. Oh, okay, this is a circle. So if I were to draw this circle here, okay, Z will be 1 unit away, like that. You understand? Z will be 1 unit away because Z is like that lah. So this will be 1 unit away. So equidistance, this is 1. So this is Z. So this is theta. Any issue with that? This is theta. Mod Z is 1. So length is 1. So this you must be able to draw it out. Okay. Understand this part first, slowly. What are we supposed? Okay, so I drew Z already. Now I'm going to draw P. P is essentially it's just a vector addition. If this is 1 like that, and this is Z, right? So 1 plus Z will just be 1 plus Z, which is a addition of Z here. So this is 1 plus Z. Understand? So you just have to know that adding two complex numbers is as if adding the vectors because it's the same thing. Cartesian form. So A plus BI and X plus YI is the same, exactly the same concept that you're doing. So essentially, what you're going to do is 1 plus Z will be here. This is Z, right? Right? Your vector here is Z like that. This is Z. So you just duplicate this one and put over at the A here. Okay? So this is Z also. Then this length here is how much? This length here is 1. So 1 plus Z is here. So this case here, this over here would be P, which is actually 1 plus is 1 plus Z. Okay, this is okay. 1 minus Z is just another vector addition here. This is 1 minus Z, which is actually 1 plus minus Z, right? If this is Z, then here will be minus Z lah. Or not? So what you do is you just copy this Z here. Now when I say copy means you really take a ruler and measure. If you can, you measure it. You just put it below here. Okay. Now take note, I'm not even sure whether it will be on the circle here, but all I know is actually that this is Q. The length here is 1. Okay, 1. So I'm going to erase away the circle. This is the diagram you're looking at. Yeah, done. Done deal. So this is 1. And basically you need to find what is going on here lah. Okay. You can just connect to the origin. Yes, you can just connect to the origin here. Then you will just you can just connect to origin. Yes. This is Z, so this is 1 minus Z. Yeah, you can also connect here lah if you want to. The Z to P here. Okay. So essentially just because they want you to the geometrical relationship, clearly the geometrical, so it's 1 1, all the geometrical relationship. So if this is Z to P, the length is 1, right? Any issue that because this will be a parallelogram, this will also be 1. Length here is 1. Okay. So from this diagram, OZPA is a parallelogram, but more precisely is a rhombus. Alright, it's a rhombus. Rhombus meaning the diagonal bisect the interior angle. You all understand that, right? So essentially, I repeat, only rhombus will have diagonal bisect the interior angle. Parallelogram, no. Parallelogram, if you have like this such thing as a parallelogram, right? Let's say it's like that, right? This diagonal may not intersect, okay, you just put this very far away. This diagonal, can you see it's not bisecting the interior angle? You will only intersect when it's a rhombus lah. So just take note. So if you can't tell that it's a rhombus, you're pretty much screwed for the also. Okay. So only diagonal of a rhombus will bisect the interior angle. Okay. Make sure you understand that. Okay. This is a rhombus. Yes, the whole thing is a trapezium. Yes, you're right. So, but they never ask you to explain the geometrical shape, but they just say show the geometrical relationship lah. Okay. So you're right to say, if you want, you can also put this as like parallel lines here. One parallel, right? Because like that. So as long as you can show that this shape is this is a trapezium, yes, trapezium. Now, the interesting bit is essentially showing that this is 90 degrees. Okay, this is 90 degrees. You on your diagram, if you draw to scale, you can see it's 90 degrees, right? But now you want to prove, okay, so we start off by if this is a rhombus. Actually, okay lah. It's not that bad, right? Because if this is a rhombus, I know that this is theta over 2, right? This is also theta over 2, right? Right? That is theta over 2, theta over 2. Then this side is an isosceles triangle. Then this is also theta over 2. Any issue with that? Maybe I should use another color. Now it's like everyone is just purple color. So I use this one. This is theta over 2. Theta over 2. Then this is also theta over 2. Base angle. This is a base angle of isosceles triangle, right? So this theta over 2. Then if this exterior angle over this triangle is theta, right? Because you just sum this both up, right? Be theta, right? So then this would be pi minus theta over 2. Any issue? Because this is another isosceles triangle here. Okay? Then you add this up, you realize that theta over 2 plus pi minus theta over 2 will be pi over 2. Proven. Okay, so that's our game plan. That's our game plan. So just write something. I know you probably already forgotten the terminologies for proving the angle, but you can just write something, okay? So just write down that from the diagram, more precisely. So from the diagram, okay, OAPZ is a rhombus. Okay, so hence angle POA is equals to theta over 2. Diagonal bisects interior angle. Or diagonal or rhombus. Okay. Okay. Then POA. Okay, so this people. So what you can do next is essentially angle POA equals to angle OPA is actually theta over 2 base angle of isosceles triangle OAP. Okay. Then we can use OAQ is theta over 2 plus theta over 2 exterior angle of triangle OAP. Now I know, totally understand, you may not know all these terms that you learn in secondary school, but you write any form, any explanation like that is more than enough. Like you just write what you understand. You because you need to prove, right? So you just write. So this is theta. So we get this as theta already. So you same thing. The angle of AOQ is just AOQ. Is just 180, which is pi minus theta divided by 2, which is also base angles of isosceles triangle AOQ. Okay, so this would serve as serve as pi minus theta over 2. So hence angle EOQ is AOQ plus angle POA, which is POA was what? IO2, right? Pi minus theta over 2 plus theta over 2, pi over 2 minus theta over 2 plus theta over 2, then this is proven. Okay, there you go. So this is a rigorous way of proving. So the next one should be okay, right? In terms of theta, this is it is now we know that this is 90 degrees. This is 90, right? So we want to find this one here. This is the right angle triangle here. This one. So you know that this is theta over 2. So if OP and OQ, then you just use tangent, right? Why not? Am I right? So this is right angle triangle. Then you just use Picasso. You have theta over 2 here. You can just use Picasso. So that's about it. I think it's just that you have got, look at the triangle that you drew. You have this. I'm gonna just extract it out. I'm not sure where is it at, but I'm just extract this out. OPQ. So OPQ. This is 90, right? Then this is theta over 2, right? Look at the OPQ there. This is what is important. The length here is 2. Just remember that this is 2. Just maybe you need it. So you want OP, mod OP to over OQ. So mod OP over Q is what you want to find, right? I could use tangent. Tangent theta over 2 will just give us OQ over OP. Okay? So if you want OP over OQ, that will be 1 over tangent theta over 2 lah. Right. So, but because, okay, then this will be chord lah. Chord theta over 2. But because this is the length, but the problem with the trigo ratio is because it can be negative, right? So that's why you just mod it lah. So I think this is the answer. It's just one in terms of theta, right? Okay, just one in terms of theta. So ratio of OP or OQ in terms of theta, yeah, that's it. Just modulus cot theta over 2. Just put modulus because the theta may be obtuse. If it's obtuse, then cot is negative, so you just make sure it's positive.